Good evening. Welcome to today's session. Maybe before we proceed, you can just confirm if I'm audible. Okay. Thank you so much. So I want us to proceed from where we left. Yesterday we looked at what we call introduction to vectors. Remember, we are still, this unit is on R essential. So whatever we have been doing is still introduction, part of it. So yesterday we looked at introduction to vectors. And maybe before we can start looking at the next subtopic today, I just want to pick, that is George Omondi. Are you in a position to speak?
Not really, I'm just on the road. I'm just about to get to the house.
Okay.
Maybe I can pass this one, please.
Okay, maybe let me pick. Maybe that's Naomi Musuva. Are you in a position to speak? Okay, it means most people are yet to settle. Maybe Hein, if you're in a position to speak, can you give us a recap of what we did yesterday?
Yes. Yesterday we learned about vectors and what it is, which is a basic ordered list of elements which can be of different types. To create a vector, you just specify a variable and set its value to a concatenation of comma-separated items. To get the size, you can call the length function with the variable as the input. And then also we learned, let me just check my notes. When you create a vector, it will automatically try and coerce all the data to the same type. And then you can use the sequence function to create the vector with a range of items, like from where you specify where it should start up until what value it should end, as well as you can set the steps and length of those items. We discussed creating using a distribution function to populate a vector's values. And then we also discussed how you can set the seed to get a reproducible way of getting the same values from a distribution function. And yeah, I think I can't remember if we handled the associative vectors, but yeah, no, that's basically it.
Okay, thank you so much for that. Maybe just to come in and emphasize on the key issues that you have highlighted. The first thing, we defined what is a vector, and we say that it is one-dimensional set of an array. And this, a vector, is made up of what we call elements. And those elements must be of the same data type. So we started from the definition. After looking at the definition, okay, let me admit some people. Okay, after looking at the definition of a vector, we went further and looked at how can you create vectors. And we saw that you can create vectors using three we looked at the three methods. One, using the concatenate function. Secondly, we looked at creating vectors using the sequence function. And third, we created vectors using the what do we call, like using the, it is called, okay, that word has escaped, but I'll remember and let you know. But like we are trying to randomize simulation, sorry, like we are trying to simulate, to do some kind of simulation. So those are the three. We went further and saw that despite the fact that vectors, when you are creating vectors, they must be made of data of the same type. But we saw what you call coercion, whereby like when you have a mixture of certain elements in a vector, one becomes powerful than the other. Then after that, on vectors again, we looked at vector arithmetic. We saw that we can still do some kind of arithmetic operations in our vectors. Then finally, I think we looked at what we call indexing. First of all, we say that indexing in R starts with 1. And we said the purpose of indexing is for you to be able to pick like specific, like you have several elements in a vector. Maybe you are only interested or keen to pick a specific element, and therefore that's when indexing becomes necessary. That is in R. So I think those were the main things that you were able to look into with regards to the vectors yesterday, introduction to vectors. So today, now, today there's another special kind of vectors. Before we start looking into matrices. Yes, Collins.
Yeah, sorry. Before we proceed to what's supposed to learn today, were you able to review the codes I sent to either help me identify where the issue was?
Not yet. I'm sorry for this. I'll respond tomorrow with
Okay,
regards to
sure,
the
no
same.
problem.
Yeah. Your code, then the issue of the cat as well.
Sorry?
There was the issue of those students who are
Okay.
yet to do the cat. Yeah. There's still a downtime from our providers of the system. And since there are just a few questions, as they are resolving, I'm trying to use a different platform just to transfer the questions. So sorry for that, Collins, but I'm still looking into it and I'll respond to you.
Okay, sure. Thank you.
Okay, thank you. Okay, so for those who have just joined, we want now to start. I was just giving a recap of what we learned yesterday. I was just giving a recap of what we learned yesterday. And now I want us to start and look into what you are supposed to cover. And I hope you are still working in your project folder that we created. So I want us to look at what we call introduction to factors in R. So still we go to file. You go to file. Then in the file, new file. Because I'm interested to open a new script now within my project folder. And then once you open, we can rename it. You go to save as. Then we put a name. This is introduction to factors, or you can just say factors. Yeah, you can just say factors. So when you are talking about factors, when we are talking about factors, factors are also just vectors. But factors specifically, we can say that it is a special type of a vector that is used to store what called categorical data. Categorical data uh, is data that cannot, I don't know how I can put it, but you are talking about like some kind of data that cannot take more than one form. I don't know if that's the right definition. For instance, when you are talking about countries, maybe in Africa, we are talking about South Africa, Rwanda, Kenya, Uganda, Burundi, Nigeria, and so on. So there's no day Kenya will be Nigeria and Nigeria will be Kenya. So that is categorical kind of data. Then also, when we are talking about gender, male, female, that is also some kind of categorical data. Then maybe when you are talking about occupation, there's no way, if you are maybe a data scientist, another person is a doctor, and so on, that is categorical. Another one, maybe you can talk about model of cars or vehicles. That one also is categorical. So we can say that this is a special, it is a special type of vector used to store categorical data. Maybe you can come further and say, when we are talking about categorical data, examples, maybe you can talk about the examples. You are talking about maybe gender. We are talking about occupation. We are talking about country, among many others. Example that cannot take more than one. So that is the purpose of this one. So factors are very important, especially when you reach in machine learning, what you call classification problems, like you want to classify, like classifications problem, mostly for instance, when you want to do some kind of fraud detection or whatever, you need to understand factors so that you are able to, like, you are able to deal with such kind of data when you are able to transform your data so that you are in a position to deal with it properly. So another important thing about factors is how do we create factors? How to create factors? But before we go into that, I don't know if let me see if I can share my white screen and I try to showcase something. Let me try to demonstrate something. trying to open my whiteboard. Okay, don't know why it is not opening. Let me just give the last trial in case it doesn't work here. I can just demonstrate. Okay, let me just demonstrate in R. Let me share my screen so that I can demonstrate. So, on how to create factors, I just want to demonstrate one thing. I wanted to use the whiteboard, but I don't know why it is not opening. I want us to look at the structure of objects. So when you want to create a factor, first of all, you must start with the function factor. And a function, okay, let me put it as a comment, but you start with a function factor. A function is always followed by an opening parenthesis. Then after that, you put what you call the vector object. As we say that it is a special type of vector. So you put your vector object. Then of course, inside a function, as we know that the arguments are separated by commas. So you put a comma. The next thing that you need to put is what you call the levels. Levels is an argument. So levels, then you put your levels. You are going to see what it means. You put what you call levels vector, then another comma. The last thing is what you call labels. Then labels a vector. Yeah. So this is the structure of a factor. Like when you want to create a factor, you come up with such kind of like that is the structure of coming up with a factor. So I want us to do something, an example, and I want us to do together. Let us come up with a factor called occupation. Let us come up with a factor called occupation, or you can call any other name. This occupation, I'm talking about like the kind of work maybe certain people are doing. So this vector factor object called occupation. First of all, to come up with a factor, we start with the function factor, right? And the first argument is a vector object. And remember yesterday, when we talked about how to create vectors, we talked about creating vectors using the concatenate function, the sequence function, and simulation or randomization. So, as when you look at this structure here, I'm saying the first argument is the vector object, right? So because this is occupation, I want us to come with maybe to look at three kind of occupations. Like I want us to come up with a vector that contains categorical of kind of data, and it contains like the types of job. I'm going to use WC to represent white collar job, BC blue collar job, and professional for prof. So let us come up with a vector. To come up with a vector, remember factor is a function. Given that factor is a function, that's why first of all we are opening parentheses and closing it. Then within that function, we are coming up with the vector object. And a vector object, we are creating it using the concatenate function, which is represented by small c. And since concatenate is also a function, you must open parentheses. Then after that, I want us now to put some kind of numeric, not numeric, string kind of data. So put WC. WC will represent white collar. Then another WC to represent white collar kind of job. Another WC to represent still white collar. Then BC will represent blue collar kind of job. Then again, I want us to put another WC to represent white collar. Then again, prof to represent profession. So this first section is what we call the vector object. I have created a vector object representing the type of jobs of various people. So that is called the vector object. The next stage is what we call the levels. So remember, this function on vector object, the one that started with concatenate, will end up here, right? Here. Therefore, outside that parenthesis for the closing parenthesis for concatenate, put a comma. And once you put a comma, because I want our work to be a bit organized and easy to read for anyone, after putting a comma, on your keyboard, press enter so that it goes to the next line to make your work easily readable. After that, based on our structure, you put the next argument called levels. Levels to be equal to concatenate. Remember on levels also, what did we say? Levels is equals levels vector. Levels is equals to levels vector. Therefore, we are going again to create a vector for levels. But let me tell you about one thing. Our first vector has how many elements? It has 1, 2, 3, 4, 5, 6 elements. So, yes, it has 6 elements, but the number of levels that we have are just 3. The first one is white collar, WC. The second level is BC, which stands for blue collar, then prof, which stands for professional. It's like in this class, we are of various gender here, but the levels are two, male or female. So despite the fact that we might have 10 females and maybe 5 male, the levels will remain two. So our levels here, you see levels is equals to levels vector. So we put the arguments levels is equals to, because it is a vector again, we create it using the concatenate function. So, and given that concatenate is a function, I must open the parenthesis and close it. And therefore, I'm going to put our levels. They are just three. So, again, the first one, I can put BC for blue collar job. Then we have WC for white collar. Then we have prof for profession. Then another question maybe that you might be wondering, why am I enclosing the arguments inside the vector in double quotation? Is because these are character or what you call strings in R. Then after this one now, again, you put a comma outside the parenthesis for levels, the closing parenthesis, and press enter. The main reason I'm doing this, I just want my work to be organized. Yes, we could have continued just writing in a straight line, no harm, but you see it is very difficult for you to, even if you are going to make a mistake, it can be very difficult for you to read. So the next thing I want us to do, I want us now to put the labels. I want us to label, because WC, for anyone, you can't know what WC means, right? It is very important for us to label at least, so that someone can understand. And therefore, let us come up with what called labels. Labels is an argument inbuilt in R. So labels, again, labels also we say that it is a vector, so concatenate. You open the parenthesis. BC stands for blue collar. So I can put up as blue dot collar to make it easily readable and to save on space. The next one, WC, stands for, that's white collar, white dot collar. I hope that is the spelling of, sorry, not this collar. It is a job, type of job. It is double L. It is here, I think it is A. Yeah, that's the spelling of collar. Then the last one, comma, is professional. Prof stands for professional. So you can now execute our code. So there's no error in my console window, so it means everything is okay. After that, when I type now this occupation here, occupation, I think this one, and run, you see it gives me white collar, and so on. In terms of levels, you see it is blue collar, white collar, and professional. Like what has happened now, instead of giving the abbreviations WC, WC, and so on, it is now giving us in full, like in the whole name so that anyone can understand what you are trying to mean. But as well, we can look at the structure of this occupation and see what does it mean. I hope you still remember the structure function, what it does. So when we look at the structure, first of all, it is telling us this is a factor, right? And this factor has 3 levels, right? And the 3 levels are blue collar. So because of space, that's why you can see it doesn't give us the entire. Then again, what is happening, R automatically assigns the values like 2, 2, 2. What it means, the first 2, 2, 2, it means white collar, white collar, white collar. Then BC, it automatically gives the name 1. Then again 2 here is this white collar. Then 3 is this prof. Yeah, I'm coming to the questions. Yes, let us start from Belinda.
Hello class. So I have an error. I'm trying to look for what could be the problem, but I still can't really see it.
Okay, maybe you can share your screen.
Okay.
Okay, try to, yes. So occupation, factor, first of all, factor is a function starting with small f. Yeah, execute and you see. Yeah, it is fine. Try now and type occupation before you stop sharing. Type in line number 14 occupation and run it. Then go to structure, str. We see the structure. Structure of our vector. Okay. So we are having two. So this is what I was trying to explain. Yes, Chris.
Hi, I also have the same kind of an error. Can find where I went wrong.
Okay, maybe you can just share your screen first. Okay. Object occupation not found. Yes, Michael? Michael, I see your hand is up. You want to assist?
Uh, could
Yes.
could the caption labels have affected? So I'm seeing there's a change of tone.
There's a change?
Yes, are you able to hear me?
Yes, yes. I don't think if
Am I
this.
audible?
Yes, you are audible. You are audible. Yes, Michael, proceed, please. Yes, Michael. Okay, maybe Belinda, you can come in first.
I don't know, but for me, I'm seeing here on line 10 from occupation, there must be like the,
Yeah,
okay, I don't know.
if I look through.
Sorry, I
Okay.
think let me go.
Okay, it is fine. Yes, Michael, proceed. Proceed. For me, I have seen several errors.
Okay, so just the first things I wanted him to change was the.
Yes, please proceed. I don't know if there's a delay from my end.
Okay. I think okay. So first, I just like him to change the casings of WC. Okay, on both the first line and the second line, because there's a mix up of WC small letters on line 10 and on line 11. Then also the issue of labels, if you can make it small letters.
Okay, thank you. So the first thing is all WC should be capital. Then after that, the argument labels, but yeah, all W and C, like we have used caps lock. You can choose either to use all caps lock or lowercase, but instead of mixing. Yes, Belinda.
Okay, mine is on the issue of the dashes. So now, like on line 10, there is a right after occupation. There must be a, okay, like there must be a dash between the factor and I don't know what that thing is called. So there must be at least a dash. Then on also here on labels, I can't really see very well, but I think he used the dash instead of equals.
Yeah.
And
Maybe.
also the C is uppercase. I don't know if it's might be an issue.
Okay. Maybe let us
On
solve.
line 12 where he puts labels, there is I don't know if that's an equals or a dash or an underscore.
It is equal. It is fine. Maybe let us just solve line by line. First of all, let us start with line number 10. Line number 10, inside the arguments, all ensure they are like caps lock. The WC still I'm seeing lowercase. Yes. Okay, let us now go to line number 11. WC also should be caps lock, uppercase. Sorry, just go undo. Go to edit, window to undo. Okay, it is fine. Yeah. Then line number 12, labels. The argument labels is lowercase. It should be lowercase. Labels also labels. It should be lowercase. Everything, yes. Okay, try to execute now. Let me see. Yes, go to 13, line 13 and execute. Structures, str. Like we need to know the structure of our occupation. Execute it. Yeah, so the most important thing here, because this one you will come across it in other like Python and so on, which is the main like part of the curriculum. You see, before Kelvin you come in, let me just finish this point so that I can't forget it. The most important thing when you will be doing exploratory data analysis is to understand the structure of various variables in your data. Like there's nowhere you are going again to meet whatever we are doing from line number. The most critical thing is line number 14 and to understand the output. That's the most important thing, like in advanced concept when you are doing exploratory data analysis, because one, it will assist you to know, for instance, which kind of machine learning methodology are you going to use, which kind of visualization are you going to use, and so on. That's why it is very important to understand about factors. Maybe Kelvin, you can come in.
So, sorry, I just needed a clarification on the codes. From my end, I'm seeing there's the levels and the labels. We have codes that are in caps and some that are in lower caps. What's the
Try to share your screen first so that I can see. Are you in a position to share? Are you in a position to share your screen? Kelvin, I can't hear you. I don't know if you are speaking on mute. Hello, Kelvin, I can't hear you. Kelvin, I can't hear you. Okay, maybe you can proceed when you are ready, then we can have your question. So I have mentioned the most important part of the factors, and I have said that it is very crucial in machine learning, especially before, not even in machine learning alone, even the data visualization and so on, exploratory data analysis, you are trying to understand like which kind of a model am I going to use and so on. That's the most important thing about factors, to know the structure. Then the next thing now I want us to look into before maybe we go for a break is what called matrices in R. You can just come up with a new script. You go to File, then New File, R script. Then let us go to Save As, then Matrices. Then Matrices. So this is Introduction to Matrices. So when we are talking about matrices, matrices are two-dimensional set of array, and this array is made up of vectors of same data type. So we see, okay, when we looked at vectors yesterday, we say that vectors are one-dimensional and they are made up of data of the same type. But now matrices, we are talking about two-dimensional set of array made up of vectors of same data type. So the similarity between a vector and a matrix is that the data type must be the same. If it is numeric, it is numeric, and so on. But the difference here is about the dimensions that they have. One has one dimension, another one has two dimensions. So that is the most important thing. So another thing that you need to understand about matrices is on how to create them. Creating matrices. So to create a matrix, we use a function called matrix. Matrix. That is what we use to create matrices. So I'm going to give one example, then also give one of you an opportunity to come up with a matrix. So I want just to pick one person's name here so that we don't use. Okay, let us create a matrix called that is Felicia. Let us just use your name Felicia as let us come up with a matrix called Felicia. We have said that matrices are two-dimensional set of an array made up of vectors of the same data type, right? So we have come up with a matrix called Felicia. And we have said that to create a matrix, we start with a function called matrix, right? And the first argument is the vector. We have seen various ways in which we can create vectors. First of all, I just want to use the most complicated one. I want to create my vector that has 12 elements. So this part is a vector. I want to use the complex one so that I can ask you, one of you, to demonstrate the simple way of coming up with a vector. So whatever I'm doing here, I'm coming with a vector containing values from 1 to 12 inclusive. Then the next part, argument in the matrix function, is the number of rows. The number of rows here are 3. Then the number of columns. The number of columns are 4 in this specific matrix. So if I'm creating a 3 by 4 matrix, it means it should have how many elements? 12. Like I multiply 3 times 4, it will give me 12. That's why even my elements here, I want them to be 12 in number. So when I execute, for instance, run, and come and type Felicia and run, you can see the output in the console window. That is what we call two-dimensional. Like you can see the output here. This is two-dimensional. It is not like a vector that was just in one line. So that's a simple one. The next one, I want to give you a quiz that I want someone to demonstrate. Create the same, I just want us to create the same. Okay, create a, let me say a 3 by 3 matrix. 3 by 3 matrix. Values from 1 to 9, that is elements. I want someone to create a 3 by 3 matrix, elements 1 to 9, 1 to 9, elements from 1 to 9. What else is important here? Quiz, create a 3 by 3 matrix, elements from 1 to 9, 1 to 9, comma, vector using one lady, a lady will create using the sequence function, then a gentleman will create using the concatenate function. Concatenate. Yeah. So let me, where can I put this one? Copy here. So the question, I have posted the question before we go for a break. I want us, first of all, we are starting with ladies first. We want to create a 3 by 3 matrix, and this matrix contains elements from 1 to 9, and the vector in that matrix should be created using the sequence function. That's for ladies. Then the gents will create using the concatenate function. So let us have who will take us among the ladies through the first part of our question quiz. Yes, Belinda. Let me stop sharing so that you can share. Yes, you can share your screen. Maybe you can copy the question first and paste in R, the one that I have shared in the chat.
Xavier, I already have it on line 10 though.
Okay.
Is it okay?
Yeah, I have seen. Yeah, sorry. Yes. So.
Okay. So I'll need a step by step. I'm not so conversant, so yeah. So I'm thinking maybe this is how you do it. So here we have to put the n row and let me just try. I'm not so sure. Okay, so I'm stuck there.
Okay, thank you. A good trial. Just keep on sharing.
Okay.
We still have ladies here who can support, who can just assist among the ladies in the room, who can assist Belinda just to guide her in case you have anything that you see that Belinda has done it wrong. Okay. So the first mistake, Belinda, that you have done is that we say that when creating a matrix, you must start with the function matrix. So before sequence, put the function matrix. Yes, there. Since it is a function, open the parenthesis. Why are you why are you putting the space? Hello? Yeah, matrix. Then so it means after that you see the matrix has its own parenthesis. Yes, matrix, then sequence from this from 1 to 9, comma by maybe 1 by 1 before end row. By is equals to 1. Then close that bracket first. Then comma. Yeah, then execute your code. No, you have added, I don't know why you have added another parenthesis. It should be 1. Since you have already closed the one for sequence. Yes, then type Belinda in line number 15. Run. Yeah, that's okay. Before Belinda, you stop sharing. There's another way to tackle this. The method that Belinda has used is for an experienced person. There's a simple way to do this. Who has an idea? Just using the sequence function. Before we can proceed to the gentleman in the room, there's a simple way to do this method. Yes, Felicia?
Let me try and share the screen.
Okay. Maybe Belinda, you can stop sharing. Thank you for that. Yes, you can share. Yes.
Can you see my screen?
Yes, I can see.
I think it's this one, line 13. Let me try. These developments Kenya closed major sections of its border with Somalia. Now there is talk of reopening them. As several police officers were killed in northern Kenya, bandits were unleashing terror in Upper Eastern, where the line 13, the one I've written.
Yeah, it is okay, but I don't see any difference from what Belinda has done. There's another way. Thank you for that, Felicia. It is a good trial. Maybe anyone who can assist before we go to the gents. Thank you so much, Felicia.
At about 8 p.m. Monday evening. On Tuesday morning,
Thank you. Anyone to Belinda, maybe you can reshare your screen again. Hein, you can maybe now assist.
Hi, so Melinda, in your line 12, where you have your sequence function, you can actually remove the word from equals, as well as the word to equals, and then also the by equals 1. Of course, those are default of the initial arguments.
Yeah, thank you for that. But that's not exactly what I want. So thank you all for your contributions. What I want, remember, go back, Belinda, on the definition of a matrix. We are saying that matrices are two-dimensional set of array made up of vectors of the same data type. What I could have done, in fact, I was expecting that for beginners, that's why you start from. First of all, I could have come up with first a vector. Let us try and come up with a vector called hein. So this vector, just proceed, concatenate. Sorry, we are creating using the sequence function. Sequence. No, we are creating a vector first, Belinda. Yes, sequence. That is from 1 to 9 by 1. From is equals to 1, 2, 9, by is equals to 1. Then run that line number 16 first. Then after that now, let us come up with a matrix, maybe called now Belinda dot matrix. You can call it Belinda dot matrix. Then matrix function. The first part of it is a vector, and we have already created our vector in line number 16 called hein. So you type that name hein, comma, then n row stands for number of rows. Number of rows is equals to 3, comma, number of columns is equals to 3. Then run it. Then type Belinda.matrix. Yeah, that is it. That's what I wanted. So thank you so much, ladies. Next is gents. But let us first go for a 10 minutes break. Then we come back after 10 minutes. So you can have a gentleman taking us through before we look at data frames, then we can close there. Let us proceed for a short break so that we come back. Please confirm if you are back. Okay, we can have one gentleman to lead us on the next section of the quiz. That is using the concatenate function. Anyone? Yes, Collins, let me stop sharing. Yes.
Okay, now for the concatenate function. So let me create. Let me use Joel. So we have that one. Then matrix. Then since we are using the concatenate, we'll put the concatenate function, and then open parentheses. Then we have we had 1 to 9.
Yes, as our elements.
Yes, so it will be 1. I think we use from is equals to 1. Then 2 is equals to 9. Then now we have the end row is equals to 3. Number of column is equals to 3 as well. Yes. I have an error.
It's not. I think the issue is from, because when you're using the concatenate function, you just list them.
The values.
Yes, the values.
So we have 1, 9.
1, 2 up to 9.
Okay, yeah, sure.
Yeah, sure.
Then so we can run that, yes. And then have yes.
Yeah, we have a matrix. Then there's another method just using the concatenate.
Yeah, so I think it's the similar method like the one we used in sequence, whereby I think we create the vector first, then, right? Or it's different?
Yeah, the same. We create the vector first, then we can just do it quickly. What you can do, come up with a vector, yes. Then copy, just make your life easier. Copy from concatenate. See where in line number 16, yes, from there up to, yes, copy, come and paste there, run it. Then now,
we go to
come and copy again line number 16. The whole of it, just to make your life easier. Just copy the whole of it first. Come and paste in line number 20. Then rename it first, maybe put .1 to have a different name. Okay, just give it any .1. That's now a matrix. Then remove this section that has concatenate. Yes, from there, yes, delete. Replace it with Ontario. Then comma. Yes. Then execute it. Then when you type on tail.1, okay. Yeah, that is it. Thank you so much. I think that one has been well executed. And therefore, that one now leads us to what we call, what do we call? That is data frames. So let me share so that I introduce it and maybe give you time so that you can proceed from there tomorrow. So matrices leads us now to what we call data frames. And I want us just to introduce, go to File, New File, Add Script, come up with a script and call it data frames. data frames in R. So let me just give the theory part of it. I'll repeat it even tomorrow because we want to start from there tomorrow, but let me just give so when we are talking about data frames are also two-dimensional. That's one thing about data frames. But data frames are made up of vectors of different data types. So I want you to differentiate very well between a data frame and a matrix, right? Matrix, we say two-dimensional, same as data frame two-dimensional. While matrices are made up of vectors of the same data type, because you see all the vectors in our matrices are numeric, for instance, in this case. But data frame, you can have one column, it is made up of numeric, then another one you can have is made up of maybe strings, another one is made up of booleans and so on. But you cannot have a mixture. Like in a column you have booleans and so on. So data frames, one column, and an example, for instance, let us say in this class, one column it has our names, then the next one is gender, the next one may be marks, code, and so on. So you see names will be strings, right? When we go to gender will also be factors, which are strings. When we go to maybe our ages, those are numeric and so on. That is what a data frame is. So tomorrow we will look at data frames. Then there's I'll be sharing in the course of the day some kind of data via emails. So when you come to class, ensure you download the data. There's some data I'll share. It is in form of an Excel. I'll share both via email and WhatsApp group. So there's a data set, because after data frames now we go to data importation of that CSV file. Then after that we look at data exportation in R. So that one I'll share tomorrow, so that we now look at how you can import your data. We look at data frames, how you import your data and export, because now whatever we have been doing is that it will end up now dealing with data frames and so on. So I just want to complete it here for today, so that also you can try to digest whatever we have done. So with regards to the kata, as I said, I'm trying to see how you can do those who haven't done the foundation cut. I think we can close here for today, and